Alright, this is the section that was not on the test. But it's still important, so we can't just totally skip it. So that's why we're going to still cover 2 notes and we're still going to homework on it. We do a little bit less than study before. Yes. How do we normally solve inequalities test? Well, if I was to give you an easier inequality, now calculus put all kinds of problems all over the board, so I'm sorry. It's a little crazy. But if I was to give you some sort of basic inequality like x plus 1 is less than or equal to negative 3. You would just, yeah, and by solving you mean? Oh, change the inequality, think of it as an equals, yeah. So x plus 1 is equal to negative 3. Think of it as an equal, but we don't usually really write that. But if we think of it as an equal, what are we allowed to do?
Subtract 1.
Yeah, subtract 1. You end up with x is less than or equal to negative 4, right? Done. The point is to get x alone, but what's the problem in this one? You can still think through algebraic stuff like factoring. And we could go ahead and do, that'd be a minus and a plus, right? But the dilemma is, do we just set both equal to 0? No, because it's less than 0. So we set both less than 0. And here's why. Less than 0 means what? Positives or negatives?
Negative.
So I need this multiplication to be a negative. What would need to be true for that multiplication to be a negative? Either a negative times a, or a positive times a. Stinks. We have to think about like when this guy is positive and that guy is negative, and then when that guy is, okay, that's going to get super complicated. So instead we're going to go ahead and cover a process where we don't have to test all kinds of different numbers to figure out when this guy's a positive, that guy's a negative, or vice versa. That'd be really cool. So here's the process. The process all starts with this key. Find the key numbers. For polynomials, it means find all the zeros. So in this one, what would the key numbers be for this one? Negative 2 and positive 3, because we would set each equal to 0. Now that's not the final answer, but that is a very important step in the process. Finding the key numbers. For a polynomial, we're going to find the zeros. And for a rational, you guys know the rational is like the f over g. For a rational, we're going to find two things, zeros and undefined. Now, undefined, we haven't talked about tons. It's the same thing as discontinuities. It's the same thing as places where the denominator is 0. So the shortcut for key numbers for this one is take your f, take your g, and if you have one fraction that could be less than or greater than 0, I'm just going to use less than as an example, could be or equal to, doesn't matter. But if you have a fraction with an inequality in 0, how you find your key numbers is you set the numerator equal to 0, aka f of x, and then you set the denominator equal to 0. I call it a little pitchfork. With a fraction with key numbers, you're setting the top equal to 0 and the bottom equal to 0. The top equal to 0 are the zeros. Some of you realized that last chapter, that if you're finding the zeros or the x-intercepts, you only set the top equal to 0. The bottom equal to 0 will be the undefined points. Top equal to 0 are the zeros. Bottom equal to 0 are the undefineds. So in polynomials, you just take the polynomial, you factor, set equal to 0, just like we did for the rest of chapter 2. Rational is at the top equal to 0 and the bottom equal to 0. Give you guys a couple more seconds. This whole page just says, you know what? The first thing you're supposed to do is find key numbers, and here's who or what they are. Here's who or what they are. Find the zeros. Polynomials, all the zeros of the polynomial. Rational, the zeros at the top and the bottom. Now what do we do with those key numbers? That's what the next page is for. What do we do with those key numbers? That's what the next page is for. Give you guys a little more time. A couple people are still trying to get it done. Hang in there, kiddos. We got this. Okay, you ready? Almost? What do we do with those key numbers? Well, use the following. To make this a little bit easier, we haven't really used this word sign chart this year a lot, so I'm just going to say on a number line. We need to capitalize a number line. That's not all that snazzy, is it? You guys got it all? Okay. So you take all your key numbers. You use those key numbers, or you mark those key numbers on a number line. And our goal is to see what intervals are now marked on the number line. And to check the signs. But to check the signs, we have to choose just one. If you want, I do say but by I mean just one. All you need is just one test value in each interval to check the sign. And you have to check your inequality also. Compare your signs to the original inequality. And you're looking for true or false. You're checking true or false. You're checking, does this test number, if I plug it in, does it work in the original or does it not work? If it does work, that's a part of the solution. If it doesn't work, that's a part that we need to ignore. So we only have to check one value for each interval. We only have to check one value for each interval. That one value will tell us whether that whole interval is true, aka part of the solution, or false, and hence not part of the solution. What are we looking for? What do we want? All the true ones. There could be more than one, or there could just be one interval. Now, as you guys keep writing, I'm going to go ahead and dual page so that we can see these steps as we look at our first example, which is the one that actually we've already started. So as you guys write the steps, all I'm going to do is what we've already done to catch us up. Plus 2 and minus 3, right? Yeah. Even though they are the zeros, I'm going to call them the key numbers instead. Section. Believe it or not, kiddos, you've already taken the notes for the whole section. 2.7 is done. All we need is examples. Okay. So it is a big section, but notes are done as long as you have the steps. Now it's just seeing how do we actually do it. There are really just 2 steps. 1, key numbers, find them. 2, test them. 1, find the key numbers. 2, test in between them. 1, find the key numbers, and 2, test in between them. -2 and 3. I'm just going to put them on my number line. And guys, be approximate. And I would say don't mark anything else. Just mark the key numbers. You might have 1, you might have 2, you might have 4. Mark the key numbers. We need to test in between. We need to test in between. So in between, I'm going to go ahead and test at, what's an easy number to plug in on the left of -2? I don't know, -3, I guess. I'm going to test -3. I'm going to test zeros in between. He's usually an easy one to plug in, right? I'm going to test 0 and 4. what, did you guys realize that I just kind of picked ones? Could I have chosen -4? Could I have chosen 1 or 2 or 3 or -1? Could I have chosen 3/4? I guess so, but who wants to plug in 3/4 to that? So you get to choose. You just have to pick one test point in between the key numbers. And how are we going to test it? We're going to go back to the very beginning and we're going to plug in. So, for the first interval, well guys, hold on. What interval is -3 in? On the number line, what would describe all the numbers all the way up to -2? What interval would that be? How far left does this portion of the number line go? -infinity. And how far right does this portion go? Negative. Oh, no, just this portion to the first key number. -2. Question, from the original inequality, am I allowed to equal the zeros of -2 and 3? Am I allowed to equal the zeros if it's a less than sign?
Oh, no.
No. Well, I'm just going to show you what I'm going to do. I'm going to make that 2 open, -2 open. The reason being is that we're supposed to not include the zeros. Why? Because it was not or equal to. What if it was or equal to? Oh, okay, include the zeros, yeah. Put a bracket. But don't include because that was just a less than, not a less than or equal to. So I'm going to test this interval. You'll see me do that in a second. We're going to test this interval from -2 to 3, keeping everything open, which we're not supposed to include. And then we're going to test the third interval from 3 to infinity. So I need to test this portion of my number line, this portion of my number line, this portion of my number line. If it's true, we're keeping it. It's part of the answer. If it's false, we're crossing it out and saying not today. So how do we do it? We plug in. I say, okay, let's take -3 and let's plug them into. You have two choices. You could plug -3 in here, or you could plug -3 into here to the factors. I'm going to go ahead and, just for sake of illustration, plug it into the original. So -3 squared minus -3 minus 6. We're trying to ask ourselves, is it less than 0? So when you plug in, 9 plus 3 minus 6 is 12 minus 6 less than 0. Yes or no? No. So we're going to say 6 not less than 0, so that's not part of the answer. It's false. Remember, that entire interval, all of those infinite numbers between -infinity and -2, none of them will work because this one did. Now it's time to plug in 0. 0 squared minus 0 minus 6, is that less than 0? Well, let's go ahead and solve it. 0 minus 0 is minus 6. Is this less than 0? The answer is yes. That's part of my answer. And some of you might guess on this one. Sometimes you'll be right, sometimes you'll be wrong. I've seen it where this has been false, and I've seen it where this has been true. This one, if I plug in 3 squared minus 3 minus 6, that's going to be 9 minus 3 minus 6. Ooh, I'm not supposed to be plugging in 3. I'm supposed to be plugging in my, not the key number, I'm supposed to be plugging in the test number. Did anybody figure out that was 0 and we would have been in trouble? That doesn't work. We need to figure out whether it's positive or negative. So now, okay, plugging in 4. I apologize for those of you that I made erase. 16 minus 4 minus 6, that's 6. Is that less than 0? So therefore, what is your only solution for this problem? The interval -2 to 3. So, my final solution. Solve the inequalities. X is within the interval from -2 to positive 3. Dun, 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 dun. Got it. So, walk me through the steps really quickly. What was the very first thing I did? I'm going to erase this box because that was not the final answer. It was just one step. The final answer is in that box. First step. Key numbers. And for a polynomial, that was the same thing as finding the aka factor and set equal to 0. After I have the key numbers, then what do? Mark them on the number line. See what intervals they have split the number line into and test how many points in between each of them. Just 1 point. Pick one test, plug it in, and say true or false. The true ones, we say, yep, solution. The false ones, we say, nope, not solution. So what's going to change? This is just a hint for homework. If you guys want to sketch the graph really quickly, this is the graph of x squared minus x minus 6. It's his graph. What's going on between -2 and 3? Is the graph above or below? The graph is below because whenever the graph is below, the y's are less than 0. So if you're allowed to use your graphing calculator, you can look at where it's below. Okay, sorry. That's not what I wanted you to see. I wanted you to see what's going to change when we have a rational function. Because you guys saw 2 different steps. Remember, we already took all the notes. What's going to change? Well, kiddos, how do we find key numbers for a rational function? Undefines and zeros. Good. Now, there's one little trick of this one that's going to make it a little bit messy. And that one trick is, stink. Is there a 0 on this side? But still, hold on. We can see the undefined points. Can you guys see the undefined point? What point is not allowed? 5. Denominator 5. So our undefined point, our undefined key number is 5. We can steal that from the denominator. The struggle is, how do we find the other if there's not a 0? Well, you know what? We can kind of cheat just a little bit. And we can distribute to the other side and say, wait a minute, can't you just move that guy? To find the other key number, we can go ahead and actually, if there's not a 0, we can't just set the top and bottom equal to 0. We can still set the bottom equal to 0. It's still undefined. But for the top, since there's not a 0 there, we're going to go about it another way. We're going to pretend there's an equals, and we're going to go ahead and solve. I'm going to subtract the 3x, subtract the 3x, negative x, and then add the 7, equals negative 8. My 0, even though I solve for it a little bit weirder than the pitchfork, my 0 I can solve by kind of solving like you would in the olden days for an equation. You know, like if you just saw that and there was an equal sign, wouldn't most of you have multiplied the x minus 5 to the other side? So it's a little weird when there's not a 0. If you could have just like subtracted, then maybe we could have done that, but you would have had to get a common denominator to do the pitchfork thing. So undefined, look at the denominator, steal him, and then you can think about solving him, which for a rational could be multiplying him to the other side. What am I going to do with these 2 numbers? Put them in my number line. I'm going to mark my number line sections. And guys, what am I going to do? Just like the last example. Pick one. Maybe like a, 0 sounds fun. 6, I guess. Maybe 10. But what am I going to do with each of these? Plug them into the original and say? Yes or no? True or false? So what was weird about this one? I gave you a hard rational. Oh, sorry, I might have zoomed in. I gave you a hard rational that didn't have a 0 on the other side. Once again, if it was a 0, if we had tons of time to do tons of examples, if it was a 0, we would have just said, hey, set the top equal to 0, bottom equal to 0. Since it wasn't 0, we still did the bottom to get the undefined. But then we just kind of used algebra and said, all right, fine, who's the other guy? Oh, 8. Marked him in my number line. Now it's time to test. Has anybody already plugged in 0? No, not yet. Okay, let's plug him in. We're almost there, guys. It's like the final 2 minutes. Home stretch. You gotta dig in to get to the finish line. Here we go. Plugging in 0. That'd be 0 minus 7 over 0 minus 5. So positive 7/5. Is positive 7/5 less than or equal to 3?
Wait, what?
I plugged in 0, which was 0. I plugged in 0. I'm plugging in my test number. 7 over 5, is that less than or equal to 3?
Yes.
1 2/5. Yeah. So that's part of my answer. If I plug in 6, that would be 12 minus 7 over 6 minus 5, which would be 5 over 1. Is that less than or equal to 3? If I plug in 10, 20 minus 7 over 10 minus 5, that'd be 13 over 5. Is that less than or equal to 3?
Yeah.
2 3/5.
Ooh, yeah.
My final solution, as soon as you write it down, you may be negative infinity to 5 and 8 to infinity. Wait! Are the zeros allowed to be included?
No.
Yes.
Or equal to? The 0 is! So we have to go to our 0 and say, make it closed. Undefined can never equal anything. Alright guys, I'll see you later. Rebecca, if you want to look in the chair in the back, see if it's there, just don't take it.